So the one reactant, some of them undergo oxidation and some of them undergo reduction. Can you guess which product is the product of oxidation? I've got a little trick here for you. So we've already looked at the fact that you can look at the oxidation numbers. Yes, you can say if the oxidation number goes up, then you have oxidation. If the oxidation number goes down, you have reduction. You can also say if I have electrons going in, that is reduction. If I have electrons coming out, that is oxidation. Also, if you have a very obvious system where you have added oxygens, guess what? That is oxidation. That's where the name oxidation came from. Sometimes, not all the time, but sometimes, if you add oxygens onto the atom, that is oxidation. Reduction, and this you might be familiar with from the Krebs cycle if you took Bio 12. I don't know if they still teach Krebs cycle. Probably not. Anyway, they don't teach Krebs cycle? Oh, okay. Well, anyway, we had to know whether things were being oxidized or reduced. Reduction, you add H's. Okay? This is not an every single time this works, but it's kind of a nice, very quick way. I could look at this reaction and say, this is going to be my reduction because I put on just hydrogen. And this is going to be my oxidation because I put on hydrogen, but also a whole bunch of oxygens. Okay, that makes it really quick for me to just say, oh, I know what that is. Can be nice for multiple choice. Okay. So, step 1, balancing a redox reaction. What do we do? Split the reactions apart. So, we're going to have Br2 goes to HBrO3. And we're also going to have Br2 goes to HBr. All right, so we have our 2 half reactions. Do you remember how to balance half reactions? What are the steps in balancing half reactions? Major OH says charge. Oh, if you couldn't say that with us, then you need to say it with us now. Major OH says charge. Who says what? Oh, that was sad. Who says what? Who says what? Okay. What do we use to balance the major atoms? Coefficients. What do we use to balance oxygen? H2O. What do we use to balance hydrogen? H+. What do we use to balance charge? Electrons. Okay, so let's balance our first half reaction here. Do we have any major atoms that need balancing in this reaction? We have Br. Yeah, we need to put a 2. And then O comes next. How many waters do we need? We need 2 times 3 is 6 waters, 6 H2O. And how many hydrogen do we need? We need 12, but we already have 2, so we only need 10. So watch out for that. If you've got some hydrogen there already, you don't want to add the whole bunch. And then our charge, what is the charge on the left-hand side? What's the charge on the left-hand side? 0, because nothing has a charge. So we got 0 over here. And on the right-hand side, our charge is 10 positive. So we add electrons to which side? The more negative or the more positive? Add electrons to the more positive side until it equals the other side. And so that's going to be 10 electrons. Excellent. Okay. Now, next, we're going to balance our second half reaction. Do we have any major atoms to balance? Yes, we need a 2 here for the Br. No oxygens. We will need 2 H+. What do we need to balance the charge? 2 electrons over here. Yes? Okay. Now, we want to take everything and we have split them apart. We have balanced them. Everyone, do it with me. We have split them apart. We have balanced them both. What comes next? Electrons in equal electrons out. So let's look at our electrons here. Electrons out is 10. Electrons in is 2. Do we need to multiply either of those reactions or both? Only one of them. We need to multiply the second one by 5 because that's going to give us 10. So actually what I'm going to do is I'm going to make my life really easy here. I'm just going to cross that out and put 10. I'm going to cross that out and put 10. I'm going to put 5 here, right? I'm going to just write that I'm multiplying by 5 over here just so I can keep track. And I'm taking 5 times 2 equals 10. Now, we've split them apart. We've balanced them both. We made electrons in equal electrons out. What do we do next? Add them together. So we're going to add them together. Okay, and